Hi, I'm Alan Ross. We're here at the RE Plus Conference and Exposition. We're talking to thought leaders about the future of the energy economy. So join us and enjoy. My next guest is Tim Rastall. Tim, thank you for joining us. You're with Inspect Power.
Yeah, correct.
So I harassed you the other day as you walked by, and you came back. So obviously you're a glutton for punishment, right?
Yeah, definitely.
Okay, good. Tell me a little bit about what Inspect Power does as it relates to the renewable industry.
Okay, yeah. So Inspect Power are a full-service power quality and grid connection company. So what that effectively means is we work all across that spectrum. Starting with consultancy, so that's design, simulation, and we can assess existing or new sites for power quality through simulation or measurement, and then we can diagnose power quality problems. From there, we move into solutions, so we design, manufacture, supply, commission solutions to power quality problems, such as reactive compensation, harmonic filtration, and point-on-wave switching. So for all manners of power quality issues that you can come across in the renewable industry, we're there to diagnose and solve the problems.
Power quality. I wrote a paper for plant engineering 3 years ago.
Yeah.
And they said, you write a paper on power quality. I knew nothing about it, so
right.
I did a little bit of research and I got alarmed. It's like,
yeah.
Oh my gosh, and I wrote this paper, and I know it's probably elementary to the world, but power quality is an issue right now that it's kind of almost like the dirty little secret that nobody talks about, right? Mm-hmm. We talk about battery, we talk about storage. Power quality is a problem now, but it's going to get worse.
Correct.
Why is it going to get worse?
So the primary reason is we're moving from synchronous connected generation, big spinning machines in centralized locations, to distributed inverter-based power generation. So inverter-based power generation, it's high frequency switch, and you're taking effectively DC and you're turning it back into an AC wave that then matches the network that we've already built. And that inherently brings issues such as harmonics, fault contribution, you lose inertia because it's no longer directly coupled to the network. Right. It's not a spinning machine, it's actually an inverter system. So you get all these whole host of problems where you're moving from this decentralized power generation and you're moving it out to the edges and bringing the power in.
Inverter based.
Yeah.
We've had several people today, one yesterday and several today, that are either they make inverters, yep, or they solve problems with inverters. But explain that idea that we're moving from the old step down grids, mm-hmm, to these inverter based grids. Explain in a little bit more detail why that's necessary, and as a result of that, you just kind of mentioned it in a broad thing, as a result of it, what specifically do inverters, why do they create power quality issues?
Okay, yeah. So the reason it's necessary is that, as we're moving to solar and wind, right, more likely where you're able to generate those sources are kind of on the edges of the grid, on coastal, bigger open areas where there's lots of sun exposure. Traditionally, we would have generated electricity centralized, on the big coal power stations and exported it out. So that means that the infrastructure we have at the edges isn't capable of this large amount of power that we're now generating and sending in. Where the way we're moving solar and wind, it generates power, the modern machines, right, directly to DC. We have an AC network, so that's why we need inverter systems to take that DC and change it into AC to feed it into the network. The way inverters work is they're high frequency switches that basically chop up a DC wave, and then it's formed into an AC wave that matches our network. That creates a lot of noise, a lot of harmonics on the network. It's not a clean kind of system. And one of the biggest issues, we're facing it quite a lot in the UK currently. If you think about a big turbine coal power station, it's a big moving mass. Yeah. If you have a fault on the network and the frequency slightly deviates, that machine doesn't want to change its frequency. It's got inertia, so it resists that and it supports the network. If you look at an inverter, it doesn't have that capability. It's effectively electrically decoupled from the system. So we have these faults and we don't have that inertia support. So we have a problem with stability on the network that we're currently taking on by installing synchronous condensers in the UK to provide that inertia to the system.
One of the people that we interviewed talked about inverters at the retail level. They're talking about the home level.
Yeah.
Okay.
Yeah.
So inverter problems are at scale. They're at the big coal power. They're also with they're very big biggest problem with failure of solar power, solar farms, utility grade, is inverters. So inverter failure, the whole thing fails.
Correct, yeah.
Now come down to the home. Why in the home? Inverters in a residential facility, what do they do?
Yeah, so once again, if you kind of look at the way our electronics that we use in the household and our appliances, they're actually commonly working on DC. Right. So we have an AC network and we have DC appliances.
Got it, right.
So we have to take that AC and change it to DC to power our appliances. So that's why inverters need to be there. So if you kind of think about it, we're generating power remotely, DC, we're changing it to AC, we're exporting it to our houses, and then we're changing it back to DC to wash our clothes.
We're schizophrenic. That's why the band AC/DC is so popular from Australia, is that they bring schizophrenia to all of us here. So the solutions, I mean, you can identify the problems. That's one of the things that Inspect Power does, right?
Yeah, correct.
Identify the problems.
Yeah.
Do you identify and supply the solutions, or do you just point to other solutions?
No, so we can kind of work in two different ways. We sometimes support our clients through the whole journey. So we'll do the simulations, we'll find the problems, we'll solve the problems. We sometimes just find the problems and they prefer to use a different party, or sometimes people come to us, they already have problems and we solve them. But yeah, effectively, if you've got an inverter-driven wind farm and it's creating lots of harmonics in the system, we can design passive or active filtration to dampen those harmonics and get it back within levels that are acceptable for the equipment or the grid levels. We design reactive compensation so that you can provide the right power factors at your point of connection so you can operate your system efficiently and free up more capacity from the inverter, because that's another kind of point. And then, a lot with the thing we've slightly touched on inertia. We do a lot of modeling and studies in terms of synchronous condenser applications to support that on the network. So it's right across the board.
Find the problem, solve the problem. Inspect, does that mean energy inspection? Is that where you came up with that name, or why Inspect?
I actually cannot. I didn't found the company personally, so it was two brothers that founded it 20 years ago. I do actually know the origin, but I'm blanking on the origin. But it's something to do with that.
Well, let's make it up. Let's energy inspection and making inspection perfect. So Inspect.
There you go. Yeah,
something like that. Now, about your personal background, how did you get involved with it? How did you get involved with the industry?
Yeah, so I studied electrical engineering at the University of Sheffield, and the module that was most interesting
in me. You have a Sheffieldian accent, you know that.
Yeah.
I have a son that lives in London, and now he's Cockney.
Right.
When he wants to be.
But there you go. The module that was most interesting to me was the electrical power kind of module. Yeah. So I was then looking for an internship, and I searched the terms that I was most interested in. Capacitor banks, harmonic filters, and Inspect popped up. Sent them an email, joined for an internship, joined straight after, and I've never kind of looked back since. I've kind of moved through, I've done engineering, system studies, modeling, point on wave. I became our kind of resident expert on point on wave applications, and I've now moved to effectively leading the engineering teams in our consultancy, manufacture and design departments.
Is Inspect global?
Yeah. So we work on tough power quality issues worldwide from our UK base if it's something that other people can't solve.
In Sheffield, still based in there, or London?
No, we do our engineering in St Helens, in between Liverpool and Manchester, and we manufacture in Newcastle. But we're actually we work from that base, but we're actually just established a presence in the US as well. So we have an office, officially registered company, an LLC for Inspect in the US.
Where's the location?
So that's in Delaware, where our company's registered to start off with. So we're starting to just on the consultancy side, because obviously it's not efficient to build a capacitor bank in the UK and ship it to America to solve their problems, but more on the consultancy and helping with our experience from the UK, because we have got like a higher percentage of inverter-based systems supplying power in the UK. So we've come across a lot of these issues that will start to crop up more and more in the US. So we want to help with that transition and bring our experience over here to kind of help you guys do what we did.
So you do have a global market. You look at it. You're in the problems detection, problem solution as it relates to power quality and that. Where do you think the industry is going to be 10, 15, 20 years from now? And we all know renewables are growing and all that, but just look at things from your perspective as you've seen it right out of college all the way through. Where do you think we're going to be 10, 15 years from now?
So I think it's kind of there's two major points. The first one is we're going to go more towards actual DC networks. So we've already discussed about how we go DC, AC, back to DC. If you can make a lot of that just DC, you remove a lot of the converters, you lower a lot of the losses, you're doing stuff directly, it's much more efficient. And we're going to go much more interconnected. So right now all of the power comes from the central sources, it comes to the houses and it's used. But if you think about it, as people install battery, solar, they have electric cars on their houses, we actually have sources of power down below that could serve local kind of systems and networks and be much more efficient and much more cost effective. So yeah, I'd say residentially and industrially to start with, we will see more DC networks and full DC systems and much more interconnection between devices and communications.
What do smart grids do to that whole thing? We've talked to a number of people talking about, smart grids are the future, and I've said, well, my son lacks a battery, he's got the car, he's got the solar, if he puts a battery in, he's a smart grid, right? He can give power, he can take power. But what do you think smart grids at more scale? I mean, we're talking about like utility scale smart grids.
Yeah.
What impact is that going to have on the grid power quality and everything you're talking about?
Yeah, I mean, in terms of power quality, when you move to DC systems, I mean, it's not necessarily great for Ensberg as a company because you do actually get rid of a lot of the power quality issues.
You didn't want to tell us that solution, did you?
No. So yeah, by using DC systems, you don't need reactive compensation, harmonic filtration. It's a much kind of easier system in that regard. But in terms of smart grids on a larger scale, I actually heard an interesting idea in a talk just previously that relates to this. If you were kind of thinking of a system where you had electric cars plugged in and then you had a train line passing by, instead of the power coming from a remote power supply to power the train that's passing by, you could look what a charge you have available in those electric cars, and you can then short time utilize that to power the train as it passes by, and then put the energy back into the cars. So having that smart grid interconnected devices will allow you to make those smarter decisions and make power consumption a lot cheaper.
Okay. There's a Grid Edge conference in April of next year in San Diego. In fact, they're one of our sponsors, the IEEE PES Grid Edge conference. Are you speaking at that conference, or have you all addressed it?
No.
Write a paper, speak at that conference, because it's what we're talking about. Everything you're talking about is being presented at the IEEE PES. I'm giving them a little love because I'm trying to make sure that the content that we have really fits the theme of what we're trying to do there.
Yeah.
What we're trying to do there is identify problems, identify the solutions to the problems currently, and eliminate the problems in the future. And that's kind of what you're talking about right now. But thank you so much. It's been a delight, Tim.
No problem.
Appreciate
Thank you very
it.
much. Thank you for your time.
So all of these interviews that we have conducted have been sponsored by the people behind me. The first one is the Grid Edge Conference and Exposition, which takes place in April 2023 in San Diego. The IEEE PES Grid Edge Conference and Exposition has been a long time in the making. This will be our first one, and it will be a delight. I can already tell you that we've had more papers, more panelists than we could possibly hold, and the conference itself is going to be brilliant. The second organization sponsoring us is H2Scan. H2Scan is ubiquitous in the transformer industry as the best. It's kind of like Intel, it's inside. H2Scan is a hydrogen sensing technology that is patented, that has been around for the last 20 years. It really came on strong as transformer hydrogen became a problem. DGA recognized by IEEE. And I just thank the people at H2Scan. They are also in electrolyzers, fuel cells, battery storage, but hydrogen safety is incredibly important. They're in refining, in processing, so H2Scan, thank you. Lastly, RE+. We are at the Renewable Energy Plus Conference and Exposition, and as we close this one out, I want to thank them for allowing us to conduct these interviews here, for allowing us to be part of their incredible conference. It's been enormous. Been 27,000 people that have attended this conference, and you can tell the energy, the excitement that's taking place within the renewables industry, so thank you, RE+. It's been a delight to do these interviews, and I hope you've enjoyed them.